Hey everybody, let's greet each other properly in here. Good morning. This is Mr. Ainsworth, and we're getting into a new technique called factor by grouping. And it's used for many different types of polynomials, but this time we're going to be taking a look at polynomials with four terms. And believe it or not, where the highest degree is 3. All right, but before we do that though, let's review what we did in last lesson here, and let's factor out the greatest common factor, the GCF. So we start by looking at the 6 and the 48, the lead coefficients. Okay, the coefficients. Everybody say coefficients. All right. We've got 6 and 48 here, and the question is what divides into these coefficients? What's the greatest common factor of 6 and 48? Well, they're both even, right? They're both even. So 2 divides into them. But the question is, does any other factors divide into them? All right, so like 6 is divisible by 2, it's divisible by 3. 3 divides into 48 because if you add up the two digits here, 4 and 8, you get 12, and 3 divides into 12, so 3 divides in here 16 times. You can see it right here, 48 divided by 3 is 16, or 3 times 16 is 48. But is there another number that divides into both 6 and 48? Tell the person next to you. You got it, it's 6, okay? 6 divides into 48. Guess what? 6 divides into 6 one time, and 6 divides into 48 8 times. So 6 is the GCF of the coefficients here. All right, so I'm going to put a 6 down. Now here, x squared means x times x right here. That's your x squared. And this, of course, is just x. So they have one factor in common. They have one of these x's in common, so I need to factor that out as well. All right, the question is, what is left over? So when you factor out a GCF, you actually divide it out. It's almost like this. It's almost like dividing both terms by 6x here and then writing down what's left over here. We know that 48 divided by 6 is 8, and x squared divided by x is x. Or you can think multiplication here. 6 times 8 is 48, and x times x is x squared. And we know that if you factor out a 6x, we have to divide it out, and we get 6x divided by 6x, which is 1, and that's positive, so we get plus 1 here. All right, this is what we're thinking, all right, but we don't actually write it down technically. That's what we're thinking. And you check by distributing back in, okay? Distribute, 6 times 8 is 48, x times x is x squared, and then 6x times the 1 gives you your 6x here. All right, so distribute back through to check. So distribute, all right, back through to check. Just make sure you do that in your mind. Once you factor out the GCF, which is the 6x here, you got to distribute through to check your work and make sure you get that original polynomial. Okay, that is what we did in the previous section. All right, but it's going to be needed today. So let's get right into it today. Here we go. We're going to factor by grouping here. All right, and I'm going to take my look at my first group here. I'm going to underline it with a single underline. All right, that's my first group. And my second group is going to be here. And the question is, what's the GCF in the first group? And if you're looking at a lead coefficient here of 1, and you look at 1 and 3 here, both 1 and 3 are prime. Well, 1's not prime. Prime numbers are bigger than 2, but they don't have a GCF other than 1, so you can't factor out a constant. But notice that they have an x squared in common. X cubed looks like this. That's x cubed. And x squared looks like this right here, x squared, x times x. And notice that they have an x squared in common. So in my first group here, I'm going to factor out an x squared, the smaller of the two coefficients here, or excuse me, exponents. So this becomes my GCF here. Now x squared times x is x cubed plus, I'm thinking multiplying now, x squared times x, it gives me my first term x cubed, and I know that x squared times 3 gives me 3x squared. So I factor out the GCF out of the first group, and I've got positive terms here, so I'm going to put a plus sign. And out of my second group, I can see that 4 divides both into 4 and 12. It's a GCF, so I can factor out a 4. Okay, that's called the GCF. Now I know that 4 times x gives me that 4x here, plus 4 times 3 gives me that 12. Okay, so I'm thinking multiplication here, although you could do it by division. 4x divided by 4 gives me x, and then 12 divided by the 4 gives me the 3. So when you factor it out, you can divide it out, or you can think multiplication. It depends on how you were taught and how you want to think. There's multiple ways to think about it. Now notice something here. the common binomial right here and here. That's what's in common. And now what I'm going to do now, and this is new because we haven't done this yet, is we're going to factor that binomial out. Now we haven't factored out a binomial yet. We factored out constants or variable single binomial terms. But in this case, we've got the common binomial. And so what I'm going to do is I'm going to factor it out. And I get x plus 3, the quantity. Every time you say these parentheses, say quantity. All right, times the quantity, look right here, x squared plus 4. Okay, and that's what we're going to have in the second group, x squared plus 4. And notice you have a product of two binomials now. You have the common binomial, which is written right here, and then multiplied by the leftover stuff here, that x squared plus 4. And you can see that is correct too. You can take this x plus 3, multiply it by the x squared, and that's your first term. And then you got this x plus 3 right here times 4, and that's your second term. All right, that's just distributing through and checking my work. Okay, now how do you know if this is actually the correct result? Well, how do you check the factoring? This right here, how do you check this result? Well, you distribute. You multiply using FOIL. You distribute, okay, and use the FOIL technique. First, outer, inner, last. All right, and use FOIL. Okay, so let's go ahead and do that. So I'm going to rewrite my my answer right here so I can work with it. And I'm going to distribute through. Okay, so here we go. Let's check the result and make sure that we get this polynomial. So x times x squared is x cubed. Outer product is right here. X times 4 is 4x. Inner product is 3 times x squared, which is 3x squared. And my last product right here is 3 times 4, or 12. And switch these two right here, and let's put them in proper order. And we have x cubed plus 3x squared plus 4x plus 12. And you can tell that this is the same as the previous one, okay? So how do you check? Well, you distribute and you multiply them, all right, using the FOIL technique. All right, so what we need to do now is just get good at that, because going from here, my first step to my second step, that's the tricky part, okay? And that's the part that you have to get used to, and what every student tends to have difficulty with is the second step. So let's do a few more, because one example is not enough, and get a lot of practice, okay? So here we go, one more time. First group and second group. Notice that we have minuses or negative terms here, and so you have to get used to that as well. So here we go. We take a look at the GCF of 4 and 8, and that's 4. They have two n's in common here. N cubed is n times n times n. N squared is n times n. So they have this n squared in common, so I need to factor that out. And when you do that, you get 4n cubed divided by the 4n squared gives you n. Or you think multiplication, 4n squared times n gives you 4n cubed. All right, or you can think this way too. You factor out, and you start off with 3 n's here because you're multiplying 3 of them, and you factor 2 of them out. Well, you have 1 remaining. You can think of it that way too as well. Plus, because I see a plus sign here, 4n times 2 is, 4n squared times 2 here will give me that 8n squared. All right, distribute back through, and you can check your work. Okay, 4n squared times n is 4n cubed. 4n squared times 2 is 8n squared. So now on the second group here, I notice that both terms are negative. They're both being subtracted, so they're both negative. So what I'm going to do is I'm going to factor out the negative as well. And I know that 5 and 10, well, the GCF is 5 because 5 divides into both of them. But I'm not going to just factor out the 5. I'm going to factor out a negative 5. So I'm going to write that down. All right. Now when you do that, the signs are going to change here. When you factor out the negative, the signs are going to change to positive. Why? Well, we know that negative 5 times n will give me that negative 5n here. And then negative 5 times what number here will give me that negative 10. Well, it can't be a negative 2, okay, because a negative times a negative is a positive, and I don't want that. I want a minus 10. So when you factor out the negative, you got to change the sign here, because a negative times a positive is a negative, okay? Negative 5 times positive 2 gives me that negative 10. So make sure you change the sign there to plus. Now, once again, on this factor by grouping technique, these binomials are always going to be the same. And you're going to go to step 2. Now step 2 is factor out that common binomial. So you're going to start off with n plus 2, the common binomial, multiplied by all this stuff, this leftover stuff, this 4n minus 5. So you put that in quantity as well. So 4n squared minus 5. And you're done at that point. All right, you factored out the common binomial, the n plus 2. It's right here. And then you multiply that by the leftover terms, which is the 4n squared minus the 5. Okay? If you wanted to check that result, you'd use FOIL and multiply through. All right, one more time. Let's do it again, because again, this technique takes a lot of practice to get good at, but it's going to be really used in the next 2 lessons. So we're going to use it in a lot of different areas, so we need to get good at it, because it is a widely used technique in factoring. Now, on the next one here, we got 5 and 20 as their coefficients. Everybody say coefficients. All right, crazy word, but that's what it is. You have 5t cubed here and a 20t squared. Well, 5 divides into both 5 and 20. On the t cubed, we got t times t times t. On the t squared right here, it's t times t. So you can see that they have a t squared in common. So I need to factor that out as well. 5t cubed, let me see, we got to get 5t. So 5t squared times t is a 5t cubed. Okay, I factor out 2 of the t's, 1 remains. Plus, I've got 20t squared divided by 5t squared. Well, I factor out all the t's, and if I take 20 and factor out a 5, I got a 4 remaining. All right? Why? Because 5t squared times 4 gives me that 20t squared. On the second group, I know that 6 divides into both of these numbers, so I'm going to factor out the 6, and everything's positive. So I'm going to put the plus sign here. 6 times t is 6t squared, and 6 times 4, so plus 4, gives me that 24. Distribute back through, and you'll see that how you get the last 2 terms. Well, once again, you got these common binomials again, so you're going to factor it out. So let's do that. All right, I've got a t plus 4 here. That's my common binomial, multiplied by the leftover terms, the 5t squared plus the 6 right here. And so I've got 5t squared plus the 6 is my second group. All right, and if you wanted to multiply through and check the original polynomial, you could do that. And that's called factor by grouping here. All right, so what I want you to do is you try it now. We're going to pause and play. And so someone get on the on a mouse, okay? Get at the mouse and pause it before each problem, and then when you are done, go ahead and press play and check. And I want you to take yourself through the video step by step and try it first, and then check it with me and make sure you're looking good. Okay? So pause the video, please. All right, we're back now, so let's check. We're going to have our first group is 2t cubed plus t squared, and then our second group here. All right, and I can see that with the coefficients 2 and 1, I don't have a constant in common other than 1, but I do have 2 t's in common, so that's a t squared. So I'm going to factor that out. T squared times 2t will give you my 2t cubed. T squared times 1 will give me that t squared. So you have to have the plus 1 there. All right, next one, they're both negative, so we got to factor out the negative. And 7 divides into both 7 and 14, so I got to factor out the negative 7. And the signs are going to change here. Negative 7 times 2t gives me the negative 14t. And then negative 7 times positive 1 will give me the negative 7 here. Make sure you change the sign. All right, negative times a positive is a negative. Check that last one. If the factor by grouping works, these binomials will always be the same. So factor them out. So we've got a 2t plus 1 multiplied by all this leftover stuff right here, you're t squared minus 7. Okay? All right, now pause the video and try the next one. All right, we're back now, so let's check our work. I'm going to factor out a 5 here. 5 divides both into 10 and 25, so does the x squared, so we've got to factor out a 5x squared. 5x squared times 2x will give me 10x cubed minus 5 times 5 is 25, so I need a 5 there. And so 5 times 5x squared gives me the 25x squared. We're good there. They're both even here. 4 and negative 10 are both even, so we're going to factor out a 2. So plus 2 times what? Well, 2 times 2x is 4x, and 2 times a negative 5 will give me a negative 10, so we're good there. These binomials are in common, so let's factor it out. So we have a 2x minus 5 multiplied by the leftover terms, the 5x squared plus 2. So 5x squared plus 2. Okay. And on the next one here, go ahead and pause the video and give that a shot. All right, we're back now, so let's check our work. I'm going to factor out a 3x squared first. 3x squared times 2x will give me my 6x cubed, and 3x squared times 1 will give me a 3x squared. And on my second binomial here, there's nothing in common other than 1. The GCF is 1, so you really can't do anything. So I'm just going to give it a hug to make it look like a group. All right, you can put parentheses around that, that's no problem. All right. And I'm going to factor that out. So let's go for it. I'm going to take the 2x plus 1 here, multiplied, all right, by the stuff remaining, okay? And I'm going to put a 1 here so you can see the coefficient. So I'm going to multiply it by 3x squared plus 1. The coefficient is 1 when you don't see 1, okay? When you factor out that binomial, you got to have something remaining. 2x times 1 will give you that 2x plus 1. All right, so let's start that one. That was a little tricky right there because I had to make it look like a group and I had to put the 1 there. So you might want to start that and practice that later on. That happens sometimes. All right, pause the video and try another one. All right, we're back now, so let's check. So I'm going to factor out a 7x squared first. 7x squared times x, 2x, will give me my 14x cubed. 7x squared times 3 will give me my 21x squared. These are both divisible by, well, not only 2, they're divisible by 4 and also by 8. So let's try 8. And so we want to always factor out the GCF, okay? Not just a common factor, but the GCF, the greatest common factor. So 8 times 2x will give me the 16x, and then 8 times 3 will give me the 24. I made a mistake here. These binomials are not the same. Ooh, I see the mistake. Should be a 3 here. 3 times 7 is 21. So when you catch yourself making silly little errors right there, no problem, just fix them. If the factor by grouping is going to work, these binomials have to be the same. And they weren't just a minute ago because I made a little mistake. I wrote down the wrong number here. So factor that out. I get 2x plus 3 now times the remaining term, 7x squared plus 8. So 7x squared plus 8 here. All right. Go for it. Try the next one. All right. Let's check our work. Let's factor out a 2x squared first. 2 times 5 is 10, so we're going to factor 2x squared times 5x gives me my leading term, 10x cubed. 2 times 8 is 16, so I have to have an 8 here. So 2x squared times 8 gives me that second term. The third and fourth terms are both negative, so we're going to factor out the negative like I was saying. And they're both divisible by 3, so I'm going to factor out a negative 3, and that's going to change both signs. Now I know that negative 3 times 5x gives me a negative 15x, and I know that negative 3 times a positive 8 gives me a negative 24. So remember the change of sign right there. These binomials are the same, they're in common, so let's factor it out. I've got 5x plus 8 times the remaining, 2x squared minus the 3, so 2x squared minus 3. All right, only a few more to do, so let's go for it. Work on the next one, pause the video. All right, now let's check. Out of my first group, I've got a 9. I'm going to factor out, a 3x squared. I know that 3x squared times 3x gives me a 9x cubed. because 3 times 3 is 9, and x squared times x is x cubed, minus 3 times 4 is usually 12, especially today. So factor out the 3x squared times 4, and that gives me the second term. Good. Now, out of 18 and 24, both divisible by 2, 3, and 6. I don't think anything bigger, so let's try 6. So I'm going to factor out the 6. 6 times 3 is 18, so 3x here. 6 times a negative 4 gives me the negative 24, so factor out a negative 4. Binomials are in common, so let's factor it out. So 3x minus 4 times the remaining, the 3x squared plus 6. So 3x squared plus 6. All right, last one. Give it a shot. Try it. Pause the video. All right, and let's check your last one here. We got first group, second group. Out of 8 and 13, they're mutually prime, so you can't factor out a constant, but you can factor out an x squared. So let's do that. So 13x here minus 8. And then I'm going to just group up the 13x minus 8 on the next two terms, the third and fourth terms here, make it look like a group. Put a 1 in front. All right, and I see that the 13x minus 8 is in common, so let's factor it out. So 13x minus 8, and then multiplied by the leftover terms, x squared plus 1. So I've got times x squared plus 1. Let's start that one because that was a little tricky because, again, you have to just group up the third and fourth terms, put the 1 in front so you can see it, and then factor it correctly. All right. Now what you got to do is do a little bit of independent practice because, believe it or not, that's not enough to get really good. You got to do this multiple days to get good. All right, so we turn it over here and give these a shot and then check it with my answers either on my website or in class or with me personally. All right, this was a lesson on factor by grouping here. All right, give it your best shot. If it's a video, so pause and play through it. If you want to see it, you can see it again at home. All right, this is Mr. Ainsworth. I'm signing off. I'll see you in my next lesson.